Okay, so good morning everybody. So let us start our lecture today. So today is August 19, 2021. So you can see my screen, right? Everybody can see my screen.
Yes.
Okay, thank you. So one thing I forgot to. Okay. Let me give the update. First of all, I added the TS office hour here. You see that his name is Anirudh, so you can email him at this email address, and this is his meeting link, and this is the schedule for TA. Okay. So for your issues like installing IDs and configuring IDE and writing your program, so please email the person TA first. I told him to be ready to help you. Okay, there is one more update that maybe okay, I found a minor mistake in the syllabus, so I uploaded the syllabus. Let me get that new one. Let's here. Okay, so I have uploaded the old version, a PDF version of the book here. So the bookstore, I see that a student told me that the bookstore has newer version, like Java version of this book, but this course so is developed and approved by our professor, senior professor, and Abbott a few years ago. So they have not updated yet with Java. So as a requirement of this course, we need to go with C++. So as I know that in our FY program we teach C++. We don't. Sorry, give me 1 second, please. I'm getting. Give me 1 second, please. We know that in our FY program, which is C++ only in 1321, but in 1322 we do not cover C++. We cover object-oriented programming with Java and C#. So as if you know C++ or object-oriented programming with C# and Java, then C++ will be easy. So ultimately, in your computer science program, you will be learning in computer science and software engineering program. You will be learning multiple languages, 5-6 languages at least. So in this course, you will learn C++, and as long as I said, as long as you know object-oriented programming with C# and Java, it should not be a problem. Okay, but there are a lot of resources and online and there are tutorials, good books to learn C++. Okay, so that will not be an issue. So let us do a quick recap of our last lecture that we discussed in our first lecture. We discussed our syllabus. Okay, so this will be okay. We discussed our syllabus and we discussed my special communication policy. So I'm very strict about my communication policy. Please do not send me email from D2L. Please do not forget to mention your course number. Course number means not the CRN number. So I mean CSITEd section number. Course section number. That means W3. You can say CS3305 W3. That's fine. Okay. And we discuss our academic integrity and our test policy and grading policies, and we discuss missing test policy. But I got suggestion that I may need to little bit update here about the final exam compensation. So I will update this section here soon. So in case you miss your final exam, so your final exam will be compensated not only for test 1 and test 2, but it actually will be your combined, your accomplished all other tasks like previous other quizzes and then assignments and test with a 25% penalty. Okay, because the final exam will be comprehensive, cumulative, but since the test 1 and test 2 are not cumulative, so we need to include everything like your quizzes and assignments. That means if you miss the final exam, so except the final exam, all of your previous content will be considered with 70%. Okay, with 25% penalty, that means you will get 75% of your other tasks. Okay, that is the change. And what else? Now, actually, we will start our full phase learning from next week, but from this week, we will just cover our chapter 1, that is introduction. Okay. So chapter 1 is about software development phases and algorithm analysis. So if you open the book, so if you go to the book, so then the book, okay. I like you to collect the book as soon as possible. So chapter 1 is the phases of software development. In recent context, it is called software development life cycle, is DLC. But here in this book, they say shortcut SD. That means software development phases. They said phases. Okay. Software development life cycle has multiple phases like planning, designing, coding, testing, debugging, implementation, and maintenance. These 6 phases software development life cycle has. So you will learn other steps, other phases of software development life cycle in software engineering class or software development class. Okay. So let us go through these few topics quickly. Especially I will give some attention here to understand running time analysis. Okay. So in this chapter, we will learn actually the main phases of software development, mainly the development and testing and debugging, how to do this, and about big O notation, like finding how to find the efficiency of an algorithm. Okay. So these are the chapter content. Now 1 point is about specification, design and implementation, and 1.2 is running time analysis, and 1.3 is testing and debugging. Okay, so I like you, instead of me going through this content page by page, I like you to read this, spend some time and please read this. Okay, then you will get some preliminary introduction talk and then some idea. You already familiar with some of this content, and maybe you will be learning something new. Okay, so here are two things. Let us focus on this precondition and postconditions, right? So a precondition is a statement giving the condition that is required to be true when a function is called. Okay, so precondition means a previously checked condition that needs to be true in order to execute a function. Okay, like for instance, if you say when we use for loop or if loop or while, right? So we have a precondition, right? So we check the condition first. If the condition is true, then we go to the for loop, or we execute the if statement, or we go to the body of the while loop. Okay, and another thing is the post condition. Post condition is another statement that needs to be true when or after a function is completed. So that when we check, we expect something from a function, that we expect that this function will give some output. Okay, for instance, if we add up 2 and 2 the two simple numbers, right? 2 and 2 equal 2 plus 2 equal to 4, right? So here post condition will be, so when we call that function, our result needs to be 4. Okay, that is a post condition. We use mainly post condition for testing and debugging purposes. So there are some functions over here, and then some description over here about precondition and post condition. Please go through this, okay? I'm sorry. So this is a simple function. This function name is Celsius to Fahrenheit. Okay, this is the function. This is the function. This is function header line, top line, and this is the function body. This is parameter, this is function name, and this is return type. Okay, so here, so let us see the precondition and post condition over here. So precondition, we know that, for instance, if double C means for Celsius, okay, it's a variable. So variable C is a Celsius temperature no less than absolute 0. This is absolute 0 temperature, right? Okay. And then we can do in different way, but here it is done with a constant, right? So a constant in programming language declared most of the languages with constant keywords, const in C++. And type is double, and then the one norm of declaring constant is that all is in uppercase. Okay, and here is assert is a function. Okay, so assert function is mainly used for testing function. So you need to use, in order to use assert function, you need to use include assert. This is a library file for testing purpose. So assert if, that means if this C value, any C value you provide when you call this function, any value that will be checked with this minimum Celsius. This is the minimum Celsius value. If any value is greater than this, then this assert function will give true value, true result. Otherwise, it is false. Okay. So if I put temperature 270 degree, negative 270, then that is greater than this negative 273.15, right? So then at that case, this assert method will return a true value. Otherwise, any value, if you give less than this, then it will give you a false result. So then how about the value? It's exactly same as this. If you put, then you say we have equal sign over here, then it will put result true. Okay, and then it will return what it will return at the end. Is will put, for this line it will put true or false result. Let us see the output. Okay, so and this at this point, so this is a calculation, mathematics calculation, right? So whatever C value is provided over here, that will be calculated to find the Fahrenheit value corresponding, and this will be a fractional of decimal point value, so the function is returning a double value. So at the end it is returning a double value. Okay. So the post condition over here, whether the return value is a temperature, and the post condition over here, it is that it's a double, whether it is a double type value, and here that will be converted from C to F. Okay, so this is the declaration of constant in C++ style. We put all in capital number and it will semicolon. So constants mean during a program execution time you cannot change this value. Okay, now what is next? Let me see how many people are there. About 24 people. Okay. So let us make this lecture interactive. You please speak out. Okay. So if it is a face-to-face class, I would give some lecture and then I would give you some activities. Okay. But since it is not a face-to-face class, So instead of giving me lecture, so let us talk, at least some people, and then we discuss collaboratively. So do you have anything? Okay, so quiz 1, there is nothing due this weekend. I will upload the quiz 1 by this weekend. Okay, that will be due next week.
Is there any chance we can get the dates updated on when the quizzes are due?
Yes. So here you see on the syllabus. Go to the last page of the syllabus. Do you see the last page like this?
Yeah, I got it. Thanks.
So since this week is add drop week, so I'm not putting anything this week, but I'm giving you it's initially 2 weeks relax, so you will have your quiz 1 and quiz 2. So quiz 1 and quiz 2 will be based on chapter 1 and 2. Okay, when you complete a chapter, then we will give quiz on that chapter. Has anyone else any question?
So if quiz 1 is based on chapter 1 and 2, then quiz 2 is 3, 4, 3,
Yes.
5, 6, and so on?
Yes.
Got it.
When you complete a chapter, then we will give quiz on that chapter, in those previous chapters. So that at least you get the weekend to study, to recap.
Mhm. And are we allowed to have printed off sheets or anything like printed material for the quizzes?
For quizzes, all quizzes are open book.
Perfect. What about our tests?
Okay, the test. Okay, I got an email yesterday about the classroom. I am not sure yet, but maybe the test will be in campus. Maybe the test will be in campus, face to face. So even whatever it is, even in campus or you can say online from a, so as I discussed in my first lecture, so I can give test, it's open book or closed book. Okay, so I want for this one I wanted to make open book. Open book means all open printed materials, okay, not electronic materials. So in your test, let me see, let me find it. Okay, so in your test, you will be able to use any printed material or your handwritten material, okay, or hard-coded book, okay, but no electronic devices, no electronic resources. You will not allowed to open PDF file, or you will not be allowed to search on Google. But on any printed materials you can use. So this is why I encourage you to buy the book and read it and mark it, and the important thing, you highlight it and you make your own cheat sheet,
Got it. Thank you.
make your own study materials. Okay. Has anyone else any other question?
Will the quizzes and tests be more theoretical, or is it more of actually programming on C++?
No, not on programming. The assignments will be programming. Some assignments will be programming maybe, and but the quizzes will be mostly from the book, and then you will get some codes, and then you will be asked to write output, explain the behavior, or analyzing some code.
Are the
Quizzes will
quizzes
be
going
from
to be
concept.
multiple choice?
Sorry?
Are the quizzes going to be multiple choice?
Most of them will be multiple choices. Some will be multiple answers. Some will be true and false.
Okay, thank you.
We will discuss this, okay, before the quizzes from next week.
And I saw quiz 0 is not graded, right? We just have to do
Yes,
it.
no, I will not grade this one, but I will record you to take this. This will be a simple quiz. So I will have some questions based on, maybe I can grade it if I want to give some extra credit. At the end of the semester, if I want to give some extra credit, then I will consider this quiz one. Quiz 0.
Okay, thank you.
Quiz 0 mainly will come from the syllabus and our policy. So I will be finalizing our policies. Maybe I got a recommendation to update only this part. As I discussed from this part of the syllabus, especially that the professor recommended me not to use only test 1 and test 2 for missing final, but to cover other things like your quizzes and assignments, previous complete quizzes and assignment, everything. So I will rewrite this and then I will get approved and I will upload this one. And when I finalize it, then I will upload the quiz 0. So anyone else has any question? So let us go to the next topic. So running time analysis. So running time means actually how much time an algorithm or a program or a process takes to complete it. Unknown caller. Sorry. So in our daily life, in our real life, we compare one thing with another thing, one item with another item, but based on some characteristics like whether this item is costly or that item is costly, more costly, or this item is cheaper, that item is cheapest, or whether one item is heavy, another item is lightweight, whether one item is close, another is far, compared to this, right? So, but when we develop our algorithm and we analyze algorithm, especially when we organize our program, we analyze our program based on its efficiency, and efficiency is measured with running time, how much time it takes. Okay, so there are many ways to measure the efficiency of an algorithm. The more The reliable way, for instance, the more way is do some reliable ways to do some mathematical calculation. Okay, the book has some anecdotal example. You may read this. You please read this. I may have some quiz questions from the book. Okay. For instance, let me give you some example. You are adding up some numbers like 1, 2, 1 plus 2 plus 3 plus dot 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 up to n numbers, right? So here you are writing a program to add some numbers. Okay. So numbers are very is simple sequential number 1, 2, 3, 4, 5, all the natural numbers. Okay. Then we can think how much time it will take for you to do this calculation. Okay. So apparently it says there are n numbers, right? So I need to add up n numbers. Okay, so but how an electronic device or a computer adds up two numbers, some numbers, they add up two numbers, right? The first two numbers are added and the result is added with the third number. Again we'll get another result. That result will be added to the next number, and it goes something like this, right? So it's a sequence, is a series, right? So we know that from our mathematics course. So if we have n numbers 1 to n, then if you add up these n numbers 1 plus 2 plus 3 plus n, we will come up with an equation like this, right? N into n plus 1 divided by 2. This is from your mathematics course. We will get this to add 1 plus 2 plus 3 plus dot dot n. So if you rearrange this, then you will get like this, and then finally you will come up with series n into n plus 1 divided by 2. This is the formula to find sum of n numbers, right? So from this formula, we will use this formula to find the efficiency or running time of an algorithm. Okay, so we know that, for instance, here if we multiply n by n plus 1, so then we will get n squared plus n divided by 2. It's very simple, right? Then so 2 is a constant over here. Okay, so we'll come up with this. So there are some notations. One is called big O notation. Okay, to measure to denote the efficiency of an algorithm. So big O(n), that means in the worst case. Worst case means if you have a very large n. So for instance, here we do not know the value of n yet. It can be 5, it can be 6, it can be 500, it can be 600, it can be 1 million, or a very large number, 1 billion, very large number. Okay, so summing up the numbers from 1 to 1 billion will be very tedious unless we use this formula. So the big O notation, it says in the worst case, for instance, the large L, what will be that how much time it takes to accomplish this task. So it is written as a big O. So we say, so in this formula, in this expression, what is the dominant term? N squared, right? So it has n squared so So here it has n squared so it has n squared plus n divided by 2. Like here n squared is a dominant term for larger n. Okay, so for this kind of quadratic expression, that any expression that has the highest term, dominant term squared, so we will see that in the worst case its time complexity will be n squared. We say this. Okay. So in case of quadratic expression, like in the previous, like this, okay, so we say that our running time, it will take big O n squared. You will learn this in your our algorithm analysis course later, next semester. Okay, but here just some idea. Okay, but you have, if you have another expression that is not quadratic, okay, for instance, if you have so if you have running time, for instance, this is Tn, time of n equal to 2n plus maybe 30. The running time will be big of n, big O of n. But here, if you have something like this, 1 plus 2 plus up to n, right? So we got this, and then we know that this is n into n plus 1 divided by 2. So ultimately, here is the dominant term is n squared. So running time will be squared. So this is quadratic, and this is linear time. Okay, linear time. This is, yeah. There may have other time like logarithm time. Okay. There may have another time like logarithm time. So logarithm time. Or there may have another other expression. So here logarithm means, so there is base. So LG log means it may be base 10. It may be base 10, or it may be base 2, or it may be base E. So in general, when you say log n means base 10. When you say LG log n, then you see base 2. And whenever you say ln of n, then base E. Okay, so this base A is mainly used for mathematics and old-fashioned, and in computer science we will be using mainly sometimes base 2 and then base 10 or 10. So remember this term, okay? Log means base 10. At least this book has. So if you have number, for instance, log, so base 10 here, or if we say log, then we do not need to write base 10, is implied. I mean 1000 equal to, and you know what is the value of this? Equal to log of 10 to the power 3. So we know that log AA is equal to 3. And if we have log LG base 2, LG means base 2, (1000), it is close to 10. It's not 10, but it's close to 10. So as we know that 2 to the power 10 equal to 1024, right? So if I would have log of 1024, then I could say this is log of, since base 2 to the power 10 so that is equal to 10. Okay, but since it is not 1024, it's 1000, so it is close to 10. It will be 9 point something. Okay, but for a log ln, you say ln 10 or 1000 equal to, you need to use a calculation. Okay, you can use a calculator or do equal to 3.3 something, right? The natural e value. So do this calculation, okay? So you will get some quiz questions like this. Okay, has anyone any question about this? You would understand?
Would you recommend going through the book and doing the practice problems?
Not all problems, but I will cover the important problems in lecture. So whatever in the lecture, please give attention whatever I discuss, and then I give you some work to do. For instance, here today I completed log 10 of 1000, right, with base 10, log 2000, and I said ln 1000. I kept it for you to do the calculation. So spend some time to do this calculation, okay? Something like this.
Got it.
Anyone else has any other question? Give me 1 second. Now let us go to the remaining part. Okay, so whatever we learned from here, that so logarithm expression, it takes less time, right? If your expression can be, if your algorithm can be fallen into an in logarithm step, then it takes less time. For instance, here you see, for the anecdotal information they discuss here, if number of stairs equal to n, okay, then is n equal to 10, then it will take, for log n with 10 base it will take 2. For linear it will take 30. For quadratic is 120. So the for quadratic, so it is getting larger, and for the linear, for the logarithm, it takes less time, right? Okay, so read this topic, please. The analysis of C++ functions. So please read this, and complete this and practice this problem. Okay, the problem is given here, and then you have some sample output. Okay. So in a quiz or test, you will be given some expression like this, and then you will be asked to find the time complexity. Okay. Okay, before I go through the testing and debugging section, let me give you another example. Okay, so this part is from my another lecture, algorithm analysis lecture. So, but I think I plan to discuss this. I think this will be a good example for you to understand. Okay, here. For instance, this is a part from an algorithm, from a program. Okay, so it has one for loop within another for loop. This is the inner for loop. This is the outer for loop. So this one for loop is the inner for loop for this outer for loop, and this is another for loop, and it has very 5 simple statements. And if we have other some statements, maybe there are 25 statements, consider that, and these are the independent simple statements. These are not in loop. Okay, so how do we calculate the running time or complexity of this algorithm? Okay, you can do it multiple ways, but one thing is that I would go from the bottom, but the very simple statements. Okay, so we don't know how much time each of these simple statements will take, but let us consider that each of these will take 1 millisecond. So then how many milliseconds each of these take? Okay, at this point I like you to speak out. Please.
5.
So you're saying
Okay,
that
there are 25
milliseconds.
There are 25 here in the last page. There are 25 of these kind of simple statements. So if I think each take 1 millisecond, so these will take 25 milliseconds, right?
Yeah.
Okay. No matter how large n is here, so because there is no looping here, so this is 25. This will take 25 milliseconds. Okay, and then each of these will take 1 millisecond, then 5 milliseconds. Then how much total time this portion will take? This portion will be executed n times, right?
Yes.
So then n times 5. This takes 5. 5 times n time. You understand why 5n? Because there are 5 statements. This takes 1 millisecond, and this all 5 will be executed n times. So 5n. But this part is complex part a little bit over here. So this simple statement, it takes only 1 millisecond by our assumption. So then how much time it will take? The whole part will take.
N squared.
Why it is n squared? Because there is a for loop within another for loop. So this for loop will be executed. How many times this for loop will be executed?
N.
This for loop n times, right? And again, this for loop, outer for loop will be executed how many times?
N.
N times. So total execution will be of this for these statements. This total execution will be n times n equal to n squared, and this will take 5n, and this will take only 25. So the total execution time here is n squared plus 5n plus 25. Okay. So now we don't know the value of n yet. It can be a very simple value. It's not 1 but 2. It can be 2, it can be 3, it can be 4, it can be 5, or it can be a very large number. 5, 1999999, something very large number. So so until we do not know the value of n, so which one will be dominating part here? Do you know?
The
So which
dominating
part will
part
take
is n
more
squared.
time? Which part will take more time? This part, or this part?
N squared.
N squared. Okay, apparently it said n squared, but I said that until we do not know the n value. So for instance, let us think that n equal to 3. So if I have only 3 n equal to 3, so then in that case, which part is dominant over here?
5n.
5n.
Sorry?
5n.
Speak out loudly, please. You said 5n, right? So if n equal to 3, then n squared will be 3 times 3 times 3, 9. And this time, this part will be 15. But this part has 25. So this part will take 25 milliseconds. This part will take 15 milliseconds. And this part will take 9 milliseconds. So which part will take more time?
5n.
No, 25. This part. This part
Makes sense.
it says 25 milliseconds. It is constant, right? And this part it takes, you said 15, right? For n equal to 3. And this part it takes 9 milliseconds. So this which part it takes more time? This part, right?
Yes.
Okay. Similarly, for n equal to 2, for n equal to, if we say n equal to 2 or 3, so then for n equal to 2, this part will take 4 milliseconds, this part will take 10 milliseconds, this part will take 25 seconds. Still, this part is dominant. So even n equal to 4, so if say n equal to 4, so this part will take 16, right? And this part will take 20. And then this part will take still 25, right? And still this part is dominant. This part is dominant, taking more time. Okay, but if n equal to 5, then this part will, and this part will be same, and this part will be same, Okay, so then in that case we can say all of these will take same time. But for a large n equal to 500, 5,000 or 5 million, so that this part will be dominant for large n, right? So if we know n value, or we can guess n value, then we can say that which part will be taking dominating part. So whenever we say big O notation, that means we calculate, we assume for the worst case, the very large n. So in that case, we will say n squared. But if we do not use big O notation, that denotes for worst case. So for regular O, for regular time, we can say, we cannot say. That would be depend on n value. For instance, as we have seen that for n equal to 2 and 3 and 4, this last part is dominant. This will take more time. Okay, so this is the way that we do. We analyze algorithm and we find its running time. Okay. Has anyone any question?
No.
You understand, right? Okay, thank you. Now let us go back to our book, textbook. So the last part is the testing and debugging. Okay, testing and debugging these are the important steps of your program development. So no programmer can claim that I do not do any mistake in writing a program. No one can say that, okay, I will not do any mistake in my program. So everybody does. Okay, so that our goal is to know how to write a program, how to debug it. Debugging means analyzing the program output and then compare its output with our expected output. And if it is true for all cases, then it is good. Yes, testing and debugging are important steps. So testing and debugging, mainly testing are done for the boundary values. So sometimes the exceptions or program does not work for boundary values. Boundaries values beings the values in the ending part. For instance, if it's time for an hour, if our range from 0 to 23 hours, right? So it's international time. So here 0 is the 0 hour is the one boundary and 23 is the another boundary. Okay. So I like you to go through this part. So there are some tips how to debug a program. Okay. And I like you, this is my homework study for today. Use your homework. This at least read this chapter, this part of the chapter, a few pages, okay? Then you get some idea. So that we learn that this is the three important example of big O analysis are linear expression that takes n times, big O n time, quadratic expression that takes big O n squared, and logarithmic expression that takes big O log n time. Okay. Okay, so there are some. This is the solution for self-test experience. So read this and you will get your quizzes from some of these questions like this. Okay, do you have any question? Okay, as I told you that in the last lecture that I have a YouTube channel here, and then I will upload my lectures in the channel. For instance, here I will create a playlist to something. Okay, I will put the video here. Okay, has anyone any question? Okay, so I created a team, Microsoft team, and then I added all of you in the teams. You got invitation, right?
Yes.
Okay, so please accept the invitation, and I uploaded this one. So every week, please use this link. So please use the same link for all over the semester for our class meeting. Okay, if you don't have any questions, so let us wrap up today, and I will see you next week. Okay,
Thank you.
thank you so much.